Hello and welcome to today's webinar, Quality Over Quantity, Leveraging AI to Optimize Test Automation. This event is brought to you in partnership with our friends at Micro Focus and Capgemini. Before we get started, there's just a few things that you should know about today's event. My name is David Davis of Actual Tech Media, and I'll be serving as the moderator. We want this event to be educational. This is a cutting-edge topic, using artificial intelligence to optimize your testing automation, and I'm sure that you'll have questions along the way. We encourage your questions there in the questions pane of your audience console, and we'll be doing a Q&A session at the end of the event. We even have a best question prize to help encourage your questions. I'll talk more about that here in just a moment. But first, I want to call your attention there to the Handouts tab. It's there that you'll find a number of resources for additional information on today's topic. And then at the end of the webinar, I'll be announcing the winner of our Amazon $300 gift card prize. If you're watching this on demand, of course, the drawing has already occurred. The prize terms and conditions can be found in the Handouts tab. And then, as I mentioned, we have our best question prize as well today for an additional Amazon $50 gift card. Of course, you have to ask a question to be entered into the prize drawing. The prize winner will be selected and contacted after the event. And with that, I'm excited to introduce you to today's expert presenters. Welcome Ravi, who is a Chief Technologist for Global Alliances at Micro Focus. Ram Chenchu, who is a Senior Director for Digital Transformation at Capgemini. And Anand Chanda, Product Specialist for ADM Solutions at Micro Focus. Now, before I hand it over to Ravi for our first presentation, I'd like to just review the agenda for the event today. In terms of the flow of the event, Ravi will kick it off by talking about the quality challenges when it comes to leveraging AI to optimize test automation. Following that, we'll do a short poll, and I'll share the results of that poll with you. And then we'll move on to Ram's presentation, where you'll learn about how quality assurance is back and how artificial intelligence is an important part of the QA process. From there, we'll do another poll question so that you can see how you stack up with your peers on the event today, followed by Anand's presentation, where you'll learn about how to achieve continuous testing with intelligent test automation powered by AI. And Anand's got some really cool demos lined up for you. And then finally, we'll wrap it up by answering your questions live. It's going to be a great event. I'll first hand it off to you, Ravi. Take it away.
Welcome and good day to all of you. Thank you all for joining us today for this exciting session on UFT-AI. I am confident that this time investment you're doing here is well worth it. At the least, you will gain some understanding about artificial intelligence, which is omnipresent across all industries today. Later in the call, you will be able to understand from Anand what UFT-AI does and how it can help you. You can also clarify your doubts and know more from the Q&A session that would follow. We live in a beautiful world. We cherish the diversity and the interactions between the complex beings that reside within it. We are part and product of this wonderful world. It is natural that we, in our own small minds, mimic the real world and conjure up a wide variety of complex entities that interact with each other. We in IT are at the forefront of creation of complex systems, and we revel in doing so, don't we? I'm Ravi Bhagavatula, and I've been in the world of information technology for the past 30 years. And I humbly accept my share of the blame for adding to that complexity. For now, I am in the role of helping navigate the maze and solve problems for customers along with my partners such as Capgemini. Today, with the help of my colleagues Ram and Anand, together we'll share our perspective on the challenges in quality management and the solutions that are available to us and the tools to address the complexity associated with the same. The UN Global Climate Change Conference, COP26, just concluded in Scotland. I feel compelled to make some references to that and draw some parallels with our own little quality management work. Unlike climate change scientists and leaders, at least we in information technology all agree on what makes our world of IT so complex. Over a period of time, systems are more complex than ever. They've grown to be. Gone are the days when we had a monolithic application and with limited infrastructure components that did a limited set of functions and more or less behaved themselves. With the advent of cloud, virtualization, containers, microservices, and many more such technologies, the complexity has exponentially increased. Starting this millennium, we've all seen a psychological shift in the attitudes of the world. There is a culture of instant gratification. I confront this personally in my daily life with my own kids who are in their teenage years. Customers are no different. Think of services like one-day Amazon Prime shipping. I'm fairly certain that people will laugh at this in just a few years from now. The mantra is time to market, even for the smallest of initiatives, which can determine the survival and the growth of a company. And the IT landscape is changing at a very rapid pace. This almost always is an effect due to the changes in the business and market conditions. But if you are lucky to be in the cutting edge of an IT group, you serve as the cause that affects the change to the business and the market. Whatever be the case, the net result of this is tens and hundreds of changes every week to your production systems. We IT leaders walk a tightrope when it comes to finances. More for less is the name of the game. With all these challenges and that are here to stay and accelerating at a very fast pace, we are compelled to respond. And how are we doing that? Unlike the climate change leaders, we are a step ahead in this quality management world. We generally agree on the solutions that are needed to maneuver through the complexity and mitigate the challenges that I spoke about earlier. Organizations are responding to these challenges by doing several things. They are streamlining the testing processes within the lifecycle models that they use, be it waterfall, be it DevSecOps, be it Agile, by building COEs and introducing new tools to automate testing. They're hiring very skilled resources. They're training their existing resources. The net result of all these is churning out loads and loads of testing assets. And we know that more does not mean better. It just becomes what we call in the common parlance as hoarding. Test assets get stale and need to be maintained and optimized regularly. Else their value diminishes. And in fact, that itself puts a lot of strain back onto the ecosystem. And here is where smart approaches and artificial intelligence driven tools come into play. UFT AI is one such. But if AI is a silver bullet that seems to be across all industries and quality management, why is it not widespread in quality engineering? Well, here are some similarities to the climate change scientists and leaders. We need leadership, decisive leadership, and a familiar set of comprehensive set of tools that are familiar to us. And the second important one is we still battle with trust issues. Will it work? It takes time and many, many proof of success stories to get convinced. It is not just enough to have a story here and there sprinkle in, and that would change our trust in the whole system, in these products. It has to be within our domain, within our neighborhood, our colleagues who should have done it, who would have done it and reaped the success. It would be within our own industry and so on. Thankfully, this is building very fast, and we are seeing many of them come in with very good benefits. The third and the most important one that usually serves as inertia to all of us is the investment. Investment in the short term seems to be, if you look at it in the short term, it's absurd. But look at it 6 months, 1 year down the line, the benefits far outweigh the investments that you make. And it's very much necessary. With that, I will hand it over to Ram, who will talk about the current collective thinking among quality leaders across the globe and how they are reacting to it, what is their process, and where they are doing their investments. Thank you. And Ram, to you.
Thanks so much, Ravi. Excellent presentation. Really great job setting the stage. Before we hand it over to our second presenter, Ram, we have a quick poll question here for everyone out there in the audience. The question on the screen is, where do you plan to utilize, or maybe where are you utilizing AI in quality assurance activities? And the answers here, feel free to select more than one. Maybe you have multiple projects. The answers are AI will be part of our testing automation. AI will be used to generate test environments and test data. Maybe you'll use AI in test execution activities, or perhaps you use smart QA dashboards that are powered by AI. So I'll leave that poll up here for just a moment. Let everyone respond. I see lots of responses so far. Thank you for those. Once you're done responding there to the poll, I encourage you to also check out the handouts tab. There's a lot of great resources there. Intelligent automation with Micro Focus, the World Quality Report, and an excellent resource on the state of AI applied to quality engineering for 2021 and 2022. So make sure that you check out those resources in the handouts tab when you're done with the poll. All right. Thank you to everyone who responded to the poll. We do appreciate your feedback. Looks like a good distribution, really, kind of across all the different options there. And with that, I'm going to go ahead and now hand it over to our second presenter on the event today. Take it away, Ram.
Thanks, David. Good morning, evening, and afternoon to all of you, and glad to have you here today. So Ravi talked about AI quality challenges, especially around change, trust, and cost. I am here to discuss a bit more on the approach and strategy of how to use AI and ML to bring the quality over quantity perspective to quality engineering. See, over the years, we have used several frameworks, methodologies, and tools to drive quality engineering. Today, we'll focus on how do you use AI and ML as yet another framework to drive testing, whether it is test creation, test execution, or test data generation. So I've worked as a tester, an architect, a leader, 4 years in the engineering space, delivering products to market. I've always been a big proponent of the automation first strategy when it comes to quality. So currently heading the specialized testing portfolio for Capgemini in North America, where my team helps solving quality engineering and site reliability problems for our customers. I am Ram Chinchu, based out of Atlanta, Georgia. So the World Quality Report is out, and I highly recommend you grab a copy to read it. I'd like to bring some focus into the World Quality Report, which addresses this particular topic on AI and ML and what the findings were. For those of you on the call, this report is more than survey or assessment. It is co-authored and delivered yearly by Capgemini and Micro Focus, which goes into the depth about the trends, developments, recommendations in the quality engineering space. So one thing I do want to point out from the World Quality Report is QA is back. So what does that mean? In fact, we might say that we're witnessing here is a comeback of quality assurance. So now most CIOs, almost 24% of the 1750 people we interviewed value testing more than ever before, as customer experience is one of the key drivers there. So we went from waterfall to agile, monolithic to microservices, project to product teams, mobile to connected and wearable devices, now operating on 5G and edge computing platforms from our hyperscalers. So where are we going with this? Customers want features faster. Business wants IT to deliver faster than ever before. To add to all of that, COVID has also changed several operating models for our customers. So software delivery in general has transformed over the years, especially in the past 4 to 6 years. So I used to work at a major financial exchange playing the gatekeeper for the trading platform. We averaged 5 major and 8 minor releases a year. That was hectic and that was a lot. I recently left a hospitality firm as head of quality, where we went from 6 releases a year to releasing 40 plus microservices a week, right? The testing turnaround time has grown thinner and thinner over the years. So that brings us to, how do I test smarter, be more predictive? What scientific methods can I use? AI and ML is the answer. So embrace failure is the new mantra. Continuous quality is a new game. And you want to do that shifting left on QE and also shifting right on site reliability. See, AI is not there yet with quality, right? I want to be clear on this. However, it is maturing and maturing faster. So what's key is the change in attitude to adopt to implementation of AI within quality has changed. So more and more organizations have started or starting to deploy AI and ML solutions for quality engineering. We're seeing that AI is changing the way test automation routines are built, and hence how testing as a whole is done. Specifically, it's helping with the development and maintenance of automation scripts. And we'll go in at length and depth of it later on. Introducing an element of scriptless automation, self-healing, natural language-based scripts, and so on. So drive the use of AI, don't be driven by it. With 88% of organizations reporting that AI is now the strongest growth area within test activities, this brings a new era of quality engineering. It is no longer a question of testing more, it is more a question of testing smarter. So optimize the regression suites. Focus AI efforts on what matters. I would call 3 areas here, at least test data is one, product code changes, and test optimization. So invest in AI where you have the biggest quality challenges. So you automated it, or you intelligently executing what was automated. So if you had 5,000 test cases to execute, can you map your GitHub repo changes, your microservices you're testing? Can you create a quality chatbot which will set up data on the fly to execute only those test cases that mattered first? Can you automate your open source security alerts for software which was already certified and shipped to production? Can you get predictive with your customer experience, right? So those are, I would say, at least to generalize areas which matters, right? Invest in AI solutions with use cases that are targeted to the most challenging aspects of quality delivery. So what does it mean for us? For all things we do in quality engineering, self-healing and self-serving will become a deliverable soon. So invest in those areas within QE. Again, use data and test execution as the drivers for this. So the verdict is stop talking about AI and ML and start doing. It's time to transform quality engineering. So back to the World Quality Report, we interviewed roughly about 1,750 individuals across various market sectors, driving the 6 areas which we showcased earlier. Now, bots will drive a lot of things in quality engineering. So in my previous role, my team created a chatbot which will ingest data, create reservations on the fly for all the rooms we owned at any resort in Las Vegas. Now, this was integrated into a Teams channel. What this did is also enable business users, new engineers into the ecosystem, even product guys, to be more enabled to focus on product features than understanding how to generate data. So that's just an example, right? So I mean, there are multiple ways you can use that based on where your use cases are driving. So self-serving test execution. So anyone in the organization can execute the tests, especially if they are automated, right? Could that be business, product, engineering, ops, and so on. Quality engineering needs to be smarter, predictive, optimized, and faster. So here we're going to talk about a simple AI/ML approach. Based on your use case, again, you need to ingest data into some time series database of your choice. Data that comes from either your requirements, your Jira, your test execution, your GitHub repo changes, your code coverage, tool data, security vulnerabilities, and then you create a model, you train the model, which can then optimize your quality engineering capabilities within your org. So here are some use cases for AI and ML in general in quality engineering. There are a few areas for you to introduce AI, or in general, I would say test optimization, defect prediction, even end-to-end automation, root cause and predictive analysis, self-healing capabilities, either that's in data, environment, or test execution. Not the least to mention, AI ops, from a SRE or a site reliability sense, is also significantly growing as we speak. So you want to shift left and shift right using AI and ML for quality and reliability engineering to bring a scientific approach to continuous quality. So with that being said, I will turn it over to Anand with Micro Focus, who will go into the details of how the AI engine under the hood of UFT will help you increase your productivity on test automation. Thank you very much.
All right, excellent presentation. Thank you so much, Ram. I learned a lot. I really enjoyed learning about the different use cases here. I think that's really important for us to help visualize how AI can be used in QA environments. I just brought up a poll question for everyone out there that says, what has been your greatest challenge with test automation during the COVID pandemic? And we appreciate your feedback on this poll as well. I'll leave this up for just a moment here before I introduce you to our next presenter on the event today, Anand, who's got a really great presentation as well as a demo in there. So that's going to be cool. I'm looking forward to that. So the options here, I know this is a single select question. You have to select just one answer on this. And we're getting a good response rate coming in. Thank you, everyone. Once you complete the poll, of course, don't forget about the great resources that are there in the handouts tab as well. And I don't want to, taint the results here, but it looks like there's a pretty clear winner in the responses to this poll, and that is BYOD, proliferation of end user devices, platforms, and browsers. I can see that being a huge challenge, during the COVID pandemic. All of a sudden, everyone's working from home, using their own device. All right, so thank you to everyone who responded there to that poll. It's now time to hand it over to our next presenter. Take it away, Anand.
The AI technologies And you also highlighted some valuable insight from the World Quality Report. I think mainly emphasizing the fact that how AI is disrupting businesses today, especially in the QA engineering space. Uh, as goes by the saying, robots taking over the world in an evil genius way phenomenon, it's impossible to deny that artificial intelligence has made life easy by saving us loads of time, money, and energy. So today I'm going to discuss about how to achieve continuous testing with intelligent test automation that is using UFT1, which is now powered by artificial intelligence capabilities. Hi, everyone. Thank you for joining this webinar. I'm Anand Chanda. I'm part of Micro Focus ADM business unit, one of the product specialists from Micro Focus ADM Solutions. Before we get into this discussion of intelligent test automation, let me start by providing a brief overview about our functional test portfolio. We have range of solutions. Solutions ranging from code-centric to the business-centric. On the left-hand side of the spectrum, for the shift left agenda, we have UFT developer, which mainly caters to the personas like enterprise DevOps or dev test teams who would love to work being within their IDE and contribute to the functional testing using IDE of their choice and programming language and test framework of their choice. On the right-hand side of the spectrum, for the shift right, we have business process testing, which mainly caters to the business analyst, domain experts, whose focus is on defining the test processes, workflows, or whatever needed test coverage. So they can build the business components, which can be leveraged part of the test flow and later can be automated using UFT1. At the center, we have our flagship offering, UFT1, which caters to all the GUI and API testing requirements for breadth of the technologies, be it legacy technology or web, mobile, or packaged application. So this solution will cater to all the functional testing needs. This is mainly used by the centralized QA automation engineers who builds the test framework comfortable with creating the automated test. All these practitioner-specific toolings are backed up by our resilient automation and insights with the help of very robust recognition and automation engine, which we already had within our functional test solutions. But with the very recent innovation, we have artificial intelligence and natural language processing engines embedded part of the functional test solution offerings. I think this is the game changer in the QA automation space now. I'm going to discuss about this as we progress further. And on the top layer, we have digital lab on-demand solution with UFT mobile and service virtualization. UFT mobile caters to all the mobile testing requirements, be it functional or performance or security testing, and even developers can leverage the mobile device as part of this UFT mobile platform for the development and debugging purposes. Service virtualization, when you do not have an endpoint available during the testing, or sometimes it's costlier to consume those third-party services during the testing, you can actually mimic the application behavior of those endpoints, be it IoT sensors or APIs, and continue with your end-to-end testing, and you can get the true feedback. So with that brief overview about our functional testing portfolio, now let's talk about the testing journey. To understand how the complexity in testing increasing over the last few decades. If you look at early 80s, it was all about manual testing because there was no need to scale beyond manual to talk because there was no real user experience exist due to the fact that there were only limited varieties of the application endpoints. And hence, maybe just a handful of test cases should have been sufficient for the testing purposes. And as we moved to early 90s, where the desktop ecosystem was emerging, as we had a few flavors of the Windows operating system by then, and even web was emerging as we had few www kind of websites. There was need for automation, but still a limited automation was fine. So maybe hundreds of test cases should have been sufficient. As we move to the first decade of the century, where web is the king, but it was still evolving. And there is some important event happened in the mobile space. In the year 2007, Apple introduced its first smartphone, followed by which there are many other vendors introduced their version of the Android phone. I think this completely changed the testing landscape where we are today. Now we have the different flavors of the operating system. We have different browsers. We have the mobile devices with the computing power, so which changed the way how users are consuming these applications. And also, we've seen that there is an introduction of iterative development approach. I think agile kind of methodologies, and then early phases of the DevOps. Okay, so the bottom line is QA teams have more repetitive tasks to do, and the test cases have increased from hundreds to thousands. If you look at the last decade of the century, it is all digital transformation and digital first, where end user is driving everything. And it's also about scale, as Ram and Ravi mentioned, okay, how the application architectures are changing from the monolithic to the microservices architecture. And also now the testing is part of the DevOps. So QA teams need to do a lot of these tasks at a faster rate and very repetitively. Otherwise, it will not be able to cater to the increasing business demands. So now we see that these test cases have increased from thousands to tens of thousands. So looking at this trend, what is future ahead of us? Probably more things, more IoT devices, more wearable devices. And we also can't predict, what could be the number of test cases to validate such a platform. The bottom line is that we need to work smarter and definitely not harder. The world has changed, and so should the automation. Now let's talk about what it means to work smarter in our space, that is in automation space. We need to be smarter with the way how we design the test cases, and we need to be smarter with the way how we do the overall test automation and execution. It also means that we need to be smarter with the way how we do the test maintenance. As otherwise, we will not be able to support the increasing business demand. As Ram mentioned in his conversation, stop talking about AI and ML, start doing. So we at Micro Focus, we have already taken some actions and leveraging these new technologies like artificial intelligence into our solution offerings, functional test solution offerings, to actually help our customers to be smarter with the way how they do automation tasks on daily basis. And you will see that as we progress with the discussion. Even before that, let's talk about what is AI, because all this time I'm using this word as a two-letter buzzword, and also Ram highly touched upon this point. But let's understand this for a second. So AI, end of the day, it's an area of computer science that aims to provide intelligence to the machines. And I'm sure you would have heard about these terminologies like ML, deep learning, and data science. So machine learning, which is a subset of artificial intelligence, these are the set of algorithms, as Ram also mentioned, whose performance improves as they are exposed to more data over time. So basically, you will train the machine to get better at a task without explicit programming, right? And deep learning, which is again a subset of the machine learning, it uses the multi-layered neural networks for machine learning purposes, and it can learn from vast amount of data, right? And data science is all about the huge data sets, which involves gathering the data related to the problem that we want to solve, and also forming an hypothesis and running different tests, right? So we can actually build an AI software. You can train an AI to perform a simple task, or it could be a very complex ones. As you could see on the right-hand side of the screen, so in this case, this is very simple task of training an or AI model by providing various different images of the profile icon and cart icon to the training agent, and it will send the information to the AI and ML algorithms, which eventually build the model. So at the end of the testing, this particular AI model will be able to predict whether this is a profile icon or cart icon. So for that, you need to provide with a lot of input data, and you run the multiple iterations of the testing. And once you have the confidence that, okay, the AI model is able to predict with high accuracy, and then the model is ready, you can embed that into production software to solve a specific problem. So up until now, the computer vision are mainly based on the pattern matching algorithms. And even we have heavily invested, we at Micro Focus have heavily invested in AI research and involved in several official researches. And we believe that most successful AI applications are the ones that built using the pattern matching algorithms. We have the same mechanism in our UFT AI engine as well. So at the AI computer vision can recognize the features at low level to high level, very noticeable features, low level, very abstractive features, which can only be understandable by the AI systems. So in summary, so AI engine will consist of an input data, and it comparing it to the output to the expected results. As an example, when you build the AI model to recognize an cart icon, so you provide that as an input model with its interference. End of the day, it will be able to predict whether it's a cart. However, it will not be able to tell if it's not cart what it is until unless you train to do so. So in summary, when you have the AI model or AI engine ready, so you will embed that into an application to solve a specific problem. A problem could be analyzing CT and MRI scan in the healthcare domain, or a problem could be recognizing a stop sign and slowing down a car in the autonomous driving space, or it could be an automated responders and online customer support space. Please note that defining the problem statement is very, very important before you develop the AI model, and you need to understand, what is the right set of data that you need to use for the training purposes. Because there are 70% of the AI-based applications in the market have failed because they failed to define the problem statement clearly. Now let's look at in our space, what are the problems or what challenges which preventing us from scaling the test automation. So when we speak to our customers, these are the challenges that we hear. These are the main three challenges which become a blocker for scaling automation. And this also resonates well with the responses that you provided in the poll that we asked earlier. The first main problem is, even Ram and Ravi talked about this. So enterprise customers, their releases have become very frequent. I think gone are those days where they used to have multiple releases in a year, which has turned out to be now bi-weekly releases or weekly releases, or in extreme cases, maybe daily releases. Even though those nightly builds, which are part of the CI/CD process, even though you're not releasing them to the production, which builds the safety net and also provides the confidence that, okay, during the day, any check-ins made by the developer has not introduced the regression, and that's basically providing the confidence. So what is the problem for QA team with this is it's difficult to keep the pace with this change because if there are any changes introduced into the automation that can, in the application that can break automation easily. So we will see it as we progress with the discussion, how we are addressing this challenge. The second biggest challenge is the time and effort. As we talked about, application architecture is becoming complex and there are multiple endpoints to validate. First of all, QA team spent a lot of effort in designing this test case to validate on different platforms. And second, they spent tons of effort in executing those test cases. Even worse, whenever there are any changes introduced into this application, you need to put a lot of effort in maintaining those scripts. So there is a huge time and effort in designing and maintaining the test cases or test assets. And the third biggest challenge is skill set, because automation is hard. How much ever you emphasize on automation for successful DevOps, still the minority of the teams have this skill set and majority of the teams are not in a position to contribute to scale the automation. So what is the impact of these challenges is we are seeing that low automation rates, which is 30% and declining, and also the high maintenance cost, which is 50% and increasing. I think with these numbers to cater to the increasing business demands when it comes to frequent releases and keeping up with those changes, it's very, very difficult. To make my point clear, let me talk about by giving an example from today's reality. I'm sure most of you also agree and would have come across similar use cases in your workplace. Let's take this use case of automating a business process of buying an item in an e-commerce application. So this is available on omnichannel platform. That means this is available as a native mobile app. This is available as a hybrid one, also available, can be accessed using the desktop browser. So what it means is at least we need to create 4 scripts to automate the same business flow, which will lead to time to market challenges. I know automation experts in the forum might say that, okay, we don't need the 4 script. Rather, we can just create 4 different repositories and deal with single script? Yes, that is possible. But what happens whenever any changes introduced in the application? It can break the automation, and you still need to put the effort to maintaining this script, because technically these are different SDKs, Android, iOS, and web. To make my point even more clear, I've created this test automation script. I'm doing the subset of the business process that I'm talking about. Even before you buy an item, you need to do a login action. So with this action one, I've created this automated script using UFT1, which is just launching an application and clicking on the menu icon, going to the login option, enter the username and password, and click on the login button, which is pretty straightforward automation. And those of you who are automation experts, you know that this action one can be wrapped as a reusable code. Probably this particular test script is part of my other many other tests as well, because this is the basic functionality. Okay, so what happened yesterday? Our developer decided to flip these controls of menu and cart icon. They just did this UI change and did the commit. So ideally, this should not have impacted my automation, because technically we are interacting with the physical properties. But even without the developer awareness, the object properties that I'm counting on to identify the objects uniquely as possible has impacted the underlying physical properties. So now you can imagine yourself what would happen if I execute the same script again. So it will try to click on the menu icon. Instead, it will click on cart icon and try to find the login button. Probably it will not be able to. And my automation will break. So if I identify this problem during the day, and probably I'll fix my all the 4 scripts, and the safety net that you build part of the continuous testing, you'll get that safety net. Otherwise, if you miss this to fix during the day, and when the end of the day, when nightly build runs, and you come back and see next day all your associated test cases which has the script, will get impacted, and you will see all the failures. So end of the day, you do not have the safety net what supposed to have, and you do not have the confidence that whether any check-ins made during the day has not impacted any regression. So it has impacted entire CI/CD. So why is it happening? I think this is the problem no one has solved probably for a few decades, because be it any technology, whether it is web, mobile, or Windows-based application, we are trying to identify the object based on the physical object properties. So what happens whenever any changes in the application implementation, it might impact the underlying object identifiers, which leads to the automation break. So this is the problem we at Micro Focus we are trying to solve. So with this thought process, we thought, what if we could automate the business process as human sees it versus how machine sees it? What I'm talking about is, what if I give you a mobile device, iPhone device or Android device, and ask you to perform the business flow? You as a manual tester, probably you might not require 4 different scripts or physical properties to identify, because you can see these controls as they appear on the screen. So you can see these profile icon or search fields or input fields, click button with your eyes, and information will be sent to your neurons, and the brain will process that and identify that this is a profile button. You can click on it, and this is an input field. You can enter something in it. So this is how human being we recognize this object, versus how machine look at these things. They look at the binaries. They would require some physical properties like maybe CSS or XPath or some physical locators to identify these controls, either on mobile screen or web, right? So we've been looking into some AI technologies and how they can be implemented in our offerings. And so we looked into these AI major research areas like reason or problem solving, machine learning and deep learning, and perception. So if you remember, what is the problem that we are trying to solve in our space? Due to frequent releases, there are asset resilience issues. So we chosen this area of computer science perception, which mainly aims mimicking the human senses. In this case, we are leveraging this computer vision for the object recognition purposes. And we've chosen the machine learning and deep learning capabilities with the help of supervised learning for the UI elements classification and monitoring aspects. And we've chosen the natural language processing area for presenting the test case, which becomes very simple with the help of NLP capabilities. It looks almost like a plain English. So in summary, now we have UFT1 and UFT developer equipped with eyes with the help of computer vision to identify the objects same way as human does. And we have our solutions equipped with brain with the help of artificial neural networks, which can interact with and manipulate the objects naturally the way how human does. And we have natural language processing capabilities for presenting the test cases in a pretty simple way, which looks like almost plain English. So all these capabilities, you don't need to buy as an add-on. So this all comes bundled along with the UFT1 solution. All you need to do is just upgrade to the latest version and enjoy the benefits of all this artificial intelligence capabilities part of the solutions. So now I'm going to demonstrate this with the how these features works in action. So we have this demo, which is categorized into 4 parts with design, feedback, execution, and reporting. So in the design, we will see, what are the different ways how we can design the AI-based test scripts. We understand that, for developing a test script, we need the application under test. But with the AI-based scripts, we don't care, what are the physical properties. It's completely technology agnostic. So we can start designing the test even before a single line of code is developed. So what I'm saying is we can leverage the mock-up screens, which will be available much earlier, even before the development begins. So mock-up space has evolved dramatically. The 65% of the application development starts with the mock-up space as estimated by the Gartner. So this, we are talking about extreme shift left, and we have that support with the help of AI-based technologies in UFT1. Later, we will see, the feedback mechanism, which is embedded part of the UFT1 solution itself. When the object recognition, AI-based object recognition doesn't happen the way user expecting or any feedback want to be provided, you can use the embedded feedback mechanism and help us to keep our AI model up to date. And the third demo we will look into, you can execute the single script, AI-based script on multiple platforms like Chrome browser with French language and a second iteration on mobile platform on iPhone, and third iteration on Chrome browser with application under test in English language. So this is completely technology agnostic. You can have single script executing on multiple platforms. And last but not least, we have rich reporting capabilities in the UFT1, which is also extended to the UFT AI. We'll look into that. So first thing first, we'll see how to create a new GUI test using UFT AI. So we'll go to UFT, go to new and select the GUI test. We start with creating the test based on mockup as I discussed earlier. So you just need to select the directory where you have the mockup screens, and UFT AI engine will identify these controls, the ones which are highlighted with the pink color here. And all you need to do is just drag and drop to create your business flow. So that's simple it is. And later, once the application is available, you can use the AI record feature. You can interact with the application under test. And while you're interacting, you can add some checkpoints. And you can use the business process that you can just build the business process that you wanted to test against. So AFT AI engine will be able to recognize if it's an input field, and it will be able to recognize based on the visual elements as well as text-based identification. You can also add some advanced features like advanced visual relationship identifier to make the object identification even more robust. With the help of AI-based identification. So end of the day, you're just interacting with the application under test, and behind the scene, AI-based script is generated as you could see there. So once you want to enrich your test further or enhance your test, you can use the AI inspection feature as shown in this demo. The key benefits of AI-based test scripts is, as you could see, you can accelerate the test design. The AI-based test creation is pretty simple. With the help of drag and drop and AI record, it makes very simple script creation. Yet these AI-based scripts are very resilient. You can have the single script running on multiple platforms. And also you do not require great automation skills for working with the AI-based feature in UFT1. So that will also reduce the skill set barriers. Now, the second demo will talk about how to use this feedback mechanism. As I discussed earlier, we have embedded this feedback mechanism within the UFT1 itself. Users can send the feedback directly to our R&D team, and our R&D team will receive this feedback and then train our AI model, which is a continuous process, and it will help to keep our AI model up to date. So let's take a look at it. So whenever any object identification is not happened using the UFT AI or AI-based object identification, you just need to mark that control and enter the details about that control. And you can either save it locally or you can directly send it if you have registered on the Micro Focus as service. And if you want to, if you choose to not send some sensitive data, you can always pixelate it and send it. Remember, all we are capturing here is just the images, okay? And also, user is, it's not that we always collect this information. It's only when user wants to send the feedback, they can just capture that screen area and send it using this embedded service. This doesn't mean that whenever the AI-based object identification doesn't work, you are stuck. No, you can always switch back to the object property-based identification and continue with the testing. That means you have the option to use both AI-based object identification and object property-based identification in tandem in the same test. So that's how you can continue with the uninterrupted testing. And once you have the AI model updates, we publish it to the Micro Focus marketplace. With the very recent UFT1 version, we have decoupled the AI model from the UFT1 core build, so that customers can just directly connect to the Micro Focus marketplace and update the AI model separately without the need of upgrading the entire UFT version. So that's another advantage. Now let's look at execution part. So the single script for the same business flow of buying an item from an e-commerce application is getting executed on Chrome browser using a French application, and as a second iteration on an iPhone device, and third iteration on a Chrome browser using English version of the application. So now it's performing the business process of logging in and looking for an item using the Firefox browser, using this AI-based script. As a second iteration, now it's executing on iPhone device, the same business flow. And you notice on browser-based application, some places it is sign in, and in some places it is login. But we have still trained our AI model to recognize this as the login feature. So now it's executing this last iteration on using the Chrome browser. So the key benefits of this AI-based test script is you can have single script executing on multiple platforms. That's how we are increasing the coverage for different platforms. And even though if there are any application changes are introduced, you just need to maintain one single script versus multiple scripts. That will reduce the maintenance to a greater extent. And that's how QA team will be able to provide the faster feedback on the application release. At the end of the day, this is an automation ROI. You can save overall cost associated with the automation. Now, the last demo is about reporting. So now let's take a look at this. So UFT1 has rich reporting capabilities. Now you can actually, the same test that we executed in 3 iteration, you can just search for the test object that you're looking for. It will show all the details associated with that test step along with the screenshots. And it also providing the certainty of the object recognition and what AI object has been used. So all these details that are necessary for the faster analysis and problem pinpointing in a smarter way. Okay. So we also have this feature called AI Transformation Assistant. If you enable that feature and execute your existing object property based script, end of the execution in the report, it will tell you whether you can convert or replace your object property based test step with an AI based test step. It will also generate a script, a line of code. You just need to copy and replace with your existing property based test step, and you can also get rid of the your objects in the repository if there are no further dependencies. So that's how simple it is. To summarize my discussion, so these are the key benefits of leveraging AI in test automation. First of all, QA teams can focus on their prime responsibility, which is quality, rather trying to become magicians and make the things work and troubleshooting or learning the new solution to make things work. So I think they will be able to achieve at least 70% or more reduction in the maintenance cost. How we arrive at this number, if you just take the example of that omni-channel application testing, we just create 1 script versus 4 scripts, that will straightforward reduce the effort by 66%. But with the AI technology, the resiliency and accuracy will also increase this number by even higher. So in practice, I think it's possible to achieve higher number than this percentage. So it will help to increase the test coverage at least 30% or more, because as you've seen in the demo, AI based test creation is much simpler, as with the help of AI record and drag and drop features. It is much simpler. You can increase the test development speed at least by 3 times, and you can have lesser scripts versus multiple scripts to validate different application environment irrespective of the underlying technologies. It's completely technology agnostic. That will also help to have better coverage. And last but not least, because working with the AI based features is pretty simple, even those personas part of ADM teams who are not well versed with the coding scripting can easily gear up on using this feature, and so to say, you can join them to the automation party. So with this, I'll conclude my discussion and hand it over to David. Thank you.
Excellent presentation, Anand. Thank you so much. I really love the demo. That was very cool to see as well. We were planning to do some live Q&A here at the end. There's so many great questions coming in. We really appreciate all your questions, but I'm afraid we've run out of time here in our webinar schedule, and we're going to have to forego our live Q&A, but we've been answering questions electronically as quickly as we can, and we'll try to do our best to get back to everyone else electronically as well. We do appreciate your questions. And with that, I do want to announce the winner of our Amazon $300 gift card prize on this live event. This is going to Amanda Purdy from Texas. Congratulations. We'll reach out to you to deliver that prize. And we'll also be reaching out to our best question prize winner as well. Thank you again, everyone who joined us on the webinar today. Don't forget about the handouts tab. There are some excellent resources there, 4 different resources on AI and QA. So make sure that you check those out, click on those, and those will open up new browser tabs or windows. And you can keep those open, of course, after the event concludes, and check those out. Thank you again to the Actual Tech Media audience for joining us on the webinar to get as well. And I also want to thank our experts from Micro Focus and Capgemini. Great webinar. We'll see you next time. Have a good day. Bye-bye.